Hey everyone. So here we have Pascal's triangle. It turns out Pascal's triangle has lots and lots of really interesting patterns in it. But what I'm going to ask is, what's this next row, the seventh row, going to look like? I know you're saying 1, 2, 3, 4, 5, 6, 7. You already have 7 rows, Mr. Kukla. Yeah, this one actually is the 0th row. This is the first row, the second row, the third row. So I want the 7th row. Can you please write down what the 7th row would be by observing the pattern in Pascal's triangle? Okay. Pause the video, write down that 7th row, and let's compare answers. Yep, 1, 7, 21, 35, 35, 21, 7, 1. Now, how did I get that? Ah, you see the pattern? Then please give me the 8th row. Did you get 1, 1, 8, 28, 56? Oh, that's my age. 70, 56, 28, 7 and 1. Oops, 8 and 1. All right, so I don't know, maybe the last time you saw Pascal's triangle was in middle school. Maybe you've never seen this before. But this is so amazingly powerful for what we're about to do today. In assignment number, what was our assignment number for this one? Our assignment number was, I believe, 77. Yes, 77. This is assignment 77. We're talking about binomial expansions today. Okay, so what did you see? Well, that's right. This plus this equals that. And this plus this equals that. And this plus this equals that. So when I wanted the 8th row, I was adding 1 plus 7 to make 8, 7 plus 21 to make 28, 21 plus 35 to make 56, 35 plus 35 to make 70. So I'm adding these two to make that one, and these two to make that one, and these two to make that one. And so I could write out Pascal's triangle. Okay, good. Now, yeah, I'm erasing Pascal's triangle. Now we'll come back to it. It's not a waste of your time, I promise. Now the directions on our little activity say expand. And what is it that I'd like you to expand? I'd like you to expand a couple of binomials for me. A plus b squared. Okay, well, that's, a plus b times a plus b. So that's going to be a squared plus 2ab plus b squared. So will you do a plus b to the third? It is going to be a plus b times a plus b times a plus b. Ooh, and that's right. Good job, because this is 2 of them multiplied together. So we could just say, hey, couldn't I do a squared times 2ab plus b squared times only one of these? Sure. And so what would that give us? That would give us a to the third plus 2a squared b plus, that's b squared, plus a b squared plus a squared times b plus 2ab squared plus b to the third. Okay, so 1, 2, 3 times 2. I should have 6. 1, 2, 3, 4, 5, 6. Great. Are there any like terms to combine? Sure. Those can be combined, and these are also like terms. And so I end up with a to the third plus 2a squared b plus, no, because I had those to add, 3a squared b plus 3ab squared plus b to the third. Good. Can you do that? Okay. Now, the one I want you to do is a plus b to the fourth. Will you please do that binomial expansion? And in the meantime, I'm going to take these little tidbits of information and write them down. No, I don't have to write this down. Okay. Any luck? Well, I would like a to the fourth plus 4 a to the third b plus 6 a to the second b to the second plus 4 a to the first b to the third plus 1 times b to the fourth. I guess I put a 1 there too. Oh, I did that expansion without doing any foiling. How did I do that? Okay. So here's what I want you to remember. This and this one. A plus b squared. A squared plus 2ab plus b squared. All right? So my question for you is, how was I able to do this one without actually multiplying a plus b times a plus b times a plus b times a plus b? And the answer is look, 1, 2, 1. Second row. First row, 0th row. Second row, 1, 2, 1. Third row, 1, 3, 3, 1. 1, 3, 3, 1. Fourth row, 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Wow. I mean, that's really powerful. So if I ask you for a plus b to the 7th, we wrote that down, didn't we? Oof. Yeah, I wrote it down and then I erased it. So 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1, and that's my 7th. Okay, so here are my coefficients. This is going to start with a to the 7th, and you could even say 1 times a to the 7th. It just doesn't look like an a to the 7th. Plus 7 a to the 6th, because this is going down 1. And this is actually a to the 7th, b to the 0. And I'm adding 1 on the b's. So this is b to the 1st. And then 21, a to the 5th, b squared, plus 35, a to the 4th, because I keep subtracting 1 on the a's, b to the 3rd, because I keep adding 1 to the b's, plus 35, a to the 3rd, b to the 4th, plus 21, a squared, b to the 5th, plus 7, a to the 1st, b to the 6th, plus 1 times b to the 7th. So when we want to expand, gee, this is a big expansion of this nice little condensed thing. When we want to expand a binomial, well, I can just use Pascal's triangle to help me out with that. Well, that's pretty powerful. That's pretty nifty, amazing, and neat. So, yeah. And when did Pascal do this? Can you say 1600s? I mean, they could make the connection. It's just really impressive, I think. All right, so now how does this affect your life? Well, here's what I'd like to do with you. I'd like to do some expansions, okay? So, how about x plus y to the 6th? Will you give me the binomial expansion for that, please? Pause the video and give it a try. Yes, you want the 6th row of Pascal's triangle. Remember that top one all by itself is the 0th row, so don't don't think that's the first row. Or you'd be sad. Why should you be sad? No sad. Okay, to the 6th. And so what did that row look like? The one with 6? It was 1, 6, 15, 20, 15, 6, 1. So I'm going to have 1, x to the 6th, y to the 0. And, I'm just going to write it here. You don't have to, but it helps some people see that something is increasing while something is decreasing. So we've used the 1. The next term has a 6. And we're going to reduce this power by 1 and increase this power. 5, y to the 1, plus 15. Reduce by 1, add by 1, so x to the 4th, y to the 2nd, plus 20. Reduce by 1, increase by 1, plus 15. Reduce by 1, increase by 1, plus 6. Reduce by 1, increase by 1, and then finally y to the 6th. And there's my expansion. Well, that's pretty fast. Yeah, dude, that is so much faster than doing x plus y times x plus y times x plus y, x plus y, x plus y. Oh my god, I haven't even written them all down yet. Like, almost the amount of time it took me to write that, I could write out the answer. Yeah, I'm a big friend of binomial expansions. Okay, now I wonder what happens if instead of this, with 2 variables in our binomial, what happens if we have that? I know the 5th row is 1, 5, 10, 10, 5, 1. Okay, so sure, 1 times x to the 5th, 2 to the 0, plus 5 times x to the 4th, this goes up by 1, 2 to the 1, plus 10 times, this goes down by 1, this goes up by 1, plus another 10, this goes down by 1, this goes up by 1, plus 5 times x to the 1st, 2 to the 4th, plus 1 times, I guess you could say x to the 0, 2 to the 5th. Now I would like it if you tidied this up. Like, I don't need a 2 to the 0 there. I just need the x to the 5th, because 2 to the 0 is 1 times x to the 5th is x to the 5th. Here we've got 2 times 5. I definitely want you to pull those together. And this plus sign. Now we've got 2 squared is 4 times 10, 40, x to the 3rd, plus 2 times 2 times 2 is 8 times 10 is 80x squared. 2 to the 4th is 16 times 5 is 80x, plus 2 to the 5th is 32. And so there's our binomial expansion. Well, isn't that nifty? Tonight? Oh yeah, this is, there we go. This is my answer. This was an intermediate step. I did all the multiplying, and this is the tidied up version. And that's so much faster that filling those out. And now I like to believe that you did this in Algebra 2, and therefore I wonder, back in our Algebra Basics unit, why didn't you use this when we were doing those FOILing problems? Interesting. Okay, the toolkit is there. Good. What happens if we have 2x plus y to the 4th? And remember, the 4th row is 1, 4, 6, 4, 1. Will you expand that for me? How's it going? Did you do 1 times 2x to the 4th times y to the 0 plus 4, 2x to the 3rd, y to the 1st, plus 6 times 2x to the 2nd, y to the 2nd, plus 4, 2x to the 1st, times y to the 3rd, plus a tiny little y to the fourth. Okay, notice it's 2x. 2x has to be raised to the fourth, not just the x, also the 2. These are attached with multiplication. If they were attached with addition, we'd be doing a binomial expansion. If they're attached with multiplication, so I have to apply that exponent to both of them. 2 to the fourth is 16, x to the fourth. Y to the 0 is just 1, so 1 times 16 is that. Plus, okay, 2 to the third is 8. 8 times 4 is 32, x to the third y, plus 2 squared is 4, 4 times 6 is 24, x squared, y squared, plus 2 to the first is 2 times 4 is 8, x, y to the third, and then we have our y to the fourth. Okay, so watch out. Make sure you apply that exponent to any coefficients as well. All right, so why don't we make that a little more interesting? How about 2x plus 3y to the fourth? Will you please, do that one? Again, we're on the fourth row, 1, 4, 6, 4, 1. And so what's that going to look like? Well, 1 times 2x to the fourth times 3y to the 0 plus 4, 2x to the third, 3y to the first, plus 6 times 2x to the second, 3y to the second. See the powers on the first part going down by 1, and the powers on the second part going up by 1. And so then we're going to have 4, 2x to the first, 3y to the fourth. Was it to the fourth? These add up to 4, these add up to 4, these add up to 4. Oh, these should add up to 4. 3. Plus 2, 1 times 2, x to the 0 times 3y to the fourth. All right, well, let's tidy this up. 2 to the fourth is 16 times, to the 0 power is 1, so I just have 16x to the fourth thing. 2 to the third is 8. 8 times 4 is 32, times 3 is 96, x to the third y, plus 2 squared is 4. 4 times 6 is 24. 24 times 9. So 6, 3, 216, x squared, y squared, plus 2 times 4 is 8. Ooh, 3 to the third is 27. 8 times 27, 216, x, y to the third, plus, I guess I just have this. 3 to the fourth is 81, y to the fourth. Nice. There's my expansion. Hey, what happens if I do that? Well, look how I'm going to deal with that. Every place I have a 3y, I'm going to put a negative 3y. And now let's see what happens. Negative 3y to the 0. Well, negative 3 to the 0 is still 1. So nothing changes on this first one, because this is still just the number 1 times 16x to the fourth. Here, though, negative 3 to the first is now negative 3. Negative 3 times 4 is negative 12, times 8 is going to be negative 96. So that sign changes. Right? Negative 3 squared, positive 9, times 4 is 36, times 6 is positive 216. So that one doesn't change. But over here, negative 3 to the third is negative 3 times negative 3 times negative 3. Now I'm going to have a negative here now. So this one's a minus. And negative 3 to the fourth, well, negative 3 times negative 3 is 9, and times negative 3 is negative 27, times negative 3 is positive 81. So this one changed, and this one changed, because they have odd degrees, or odd multiplicities. Even multiplicities, evens, evens stay same, but those minuses, these minuses come in here. All right? Well, that's kind of exciting. Cool. Do you think you can do this now? Here, you do this one. How about 3x minus 2y to the third? Okay? I mean, you know, it could be bigger, but let's just do that one. There's a little more that I want to talk about in this video. So, how's it going? The third one, do you remember the third one? 1, 3, 3, 1. Okay, so that's going to be 1 times 3x to the third times minus 2y to the 0 plus 3 times 3x to the second minus 2y to the first plus 3x to the first minus 2y squared plus 1, 3x to the 0, and minus 2y to the third. Okay. Remember that these powers should always add up to that number. 3 plus 0, 2 plus 1, 1 plus 2, 0 plus 3. Okay? And let's tidy up. Stuff to the 0 power is 1 times 3 to the third. You get 27x to the third. And here I've got 3 squared is 9, times 3 is 27, times negative 2 is negative 54, x squared y. Here I have negative 2 squared, so negative 2 times negative 2 is positive 4, times 9 is 36x y squared. And then we've got 1 times negative 2 to the third, which is negative 8y to the third. And there's our expansion. And notice the alternating SIGNs. Cool. Nice. So, can you do that on a CFA? Can you do it on a 50-point quiz? Are you comfortable? Practice some more. But I want to move on to this one. 2x plus 3y to the 10th. No, Mr. Kukla, I don't want to write out Pascal's triangle to the 10th row. Oh my gosh, that's going to take so long. It is going to take long. And if this is bigger than 10, it's going to take a lot longer. It could even be 20. You wouldn't do that, would you, Mr. Kukla? No, I wouldn't do that. But there are other people on the planet. Maybe Mr. Paz will do that. Oh, don't do that, Mr. Paz. So, I want to actually take a little side trip for a minute. Combinations and permutations. Do you remember how a combination lock is really supposed to be a permutation lock? Well, I remember we had a formula for each of these, and the one that I'm interested in, the combination formula, C n r, is n factorial over n minus r, then factorial, times r factorial. Combination. The order does not matter. Permutation, the order matters. Right. Oh, by the way, this notation here is happy notation for math students, but we might also see, like my math teacher, she used to write it like this. That's what she meant when she said combination of n choose r. Same formula, just a different way of understanding that or stating that. And my calculator says NCR. Yeah, look. If I go over to math and here probability, look, NCR. Okay. So all of these mean the same thing. They mean this. Okay. And I don't want you to do this by hand. I'd like you to use your calculator. So could you do me a favor and use your calculator to find the following? I want a combination of 4 choose 0, combination of 4, choose 1, combination of 4, choose 2, combination of 4, choose 3, a combination of 4, choose 4. Okay, and how do I do that? Well, I'm going to use this, and on the main screen, I'm going to type in my value here. Remember, this is n comma r. So this is my n. I'm going to do 4, and then I'm going to go math, probability, and choose r. And then the number 0. Okay, and I end up with 1. So will you do these others? You need one more. Okay. 4, math, probability, and choose r, 1. And I get 4. Okay, finish these. Hey, how did it go? What did you get for this one? Did you get 6? And this one, 4? And this one, 1? What do you notice? What's the fourth row of Pascal's triangle? 1, 3, 3, 1 is the third row. 4, 6, 4, 1. I mean, I just want to spout a couple of expletives right now. Why does that work? Oh my gosh. And you know, if we had some more time, we might look into why are all these things happening? What's the connections between them? How does Pascal's triangle provide us with all these coefficients for our binomial expansions? And look, our combinations take care of creating those same coefficients that are in Pascal's triangle. So now when I see something like this, when I see 2x minus 3y to the 10th, okay, I'm going to use combinations. 10. In the last problem, we had 4. So I'm going to have a combination of 10, choose 0. Combination of 10, choose 0 is going to get the first term on the 10th row of Pascal's triangle. I still need to do 2x to the 10th times minus 3y to the 0 plus a combination of 10, choose 1 times 2x to the 9th times negative 3y to the first plus a combination of 10, choose 2, 2x to the 8th minus 3y to the second plus a combination of 10, choose 3 times 2x to the 7th times minus 3y to the third plus a combination of 10, choose 4, 2x to the 6th minus 3y to the second. No, sorry. These add up to 10, these add up to 10, these add up to 10, so this has to add up to 10. That means that's 4. Plus a combination of 10, choose 5, 2x to the 5th minus 3y to the 5th plus a combination of 10, choose 6, 2x to the 4th minus 3y to the 6th, combination of 10, choose 7, 2x to the 3rd minus 3y to the 7th. Remember, these always have to add up to that. Combination of 10, choose 8, 2x to the 2nd minus 3y to the 8th plus a combination of 10, choose 9, 2x to the 1st minus 3y to the 9th plus finally 10, choose 10, 2x to the 0 minus 3y to the 8th. Wow. Now I know it's not quite done yet, is it? It's certainly faster to finish this than it is to FOIL that out to the 10th. Oh my goodness. But I do have a bunch here still to do. I need to find all these combinations. Okay? And I'm doing the combinations with my calculator instead of having to write out Pascal's triangle to all those rows. Yeah, so let's take a look. This is, in fact, let's just take care of the combinations. This is 1, this is 10 here. So I've got 10 math combination 2. It's going to be 45. 10 combination 3. I can just go back and edit that value. It's 120. 10 choose 4. I get 210. 10 choose 5. I get 252. Plus 10 choose 6. I get 210. 10 choose 7. And I get 120. And I notice that these are the same and these are the same, so I know that this one will be 45 and 10 and 1. Okay, so see if you can do that multiplying times that multiplying times that multiplying and write out that expanded binomial. This would be 2x to the 9th, and this was a combination of 10 choose 1. Combination 10 choose 1, and then we had a combination of 10 choose 0 times 2x to the 10th minus 3y to the 0. And this was 1, and this was 10. Okay, I don't have any space to write this down. Right, yes, and don't be surprised when you get some big coefficients, because 2 to the 10, 2 to the 10th times 1 times 1. So I get 1024. 10. So this can become 1024x to the 10th, y to the 0. And then we've got this minus 3 times 2 to the 9th, 2 to the 9th times negative 3 times 10. And I get minus 15,360 x to the 9th y. Cool. Now I've got 45 times 2 to the 8th times negative 3 times negative 3 is positive 9 times 9. And so I seem to have 103,680 x to the 8th y to the 2nd. Plus, that was this one gone. Now this one. So we've got 120 times 2 to the 7th times negative 27. So I've got 120 times 2 to the 7th times negative 3 to the 3rd is negative 27. And that gives me negative 414,720. This will be x to the 7th and y to the 3rd. Slowly but surely. So here we have 210 times 2 to the 6th times negative 3 to the 4th. So I have 210 times 2 to the 6th times negative 3 to the 4th, which is minus, oh no, it's plus, because negative times negative plus 81. And that gives me 108,8640 x to the 6th, y to the 4th. Okay, that's that one. Now this one, 252 times 2 to the 5th, which is 32 times negative 3 to the 5th. I'm going to type that in, by the way, as negative 3 raised to the 5th power. I think it's negative 243. Okay, and so I get actually minus 1959552 x to the 5th, y to the 5th. Ooh, we're making headway. Now we've got 210 times 2 to the 4th times negative 3 to the 6th. Okay, so I've got negative 3 to the 6th. I've got 2 to the 4th, which is 16. And I had 210. 210. And that gives me 2449440. X to the 4th, y to the 6th. That's that one. Here, we've got our 120 times 2 to the 3rd times 3 to the negative, 3 to the negative 3 to the 7th. Okay, so that's going to be negative 3 to the 7th. 2 to the 3rd is 8. And the coefficient was 120. Okay, and that gives me minus 2099520. X to the 3rd, y to the 7th. Remember, these have to add up to that. Here, we're going to have 45 times 4 times negative 3 to the 8th. So that's an 8. That's a 4. And this is a 45. And so I get 1180,980 x to the 2nd, y to the 8th. 10 times 2 times negative 3 to the 9th. I really like this ability just to bring back the last entry and edit it. Makes things so much easier. This is times 1. No, we're doing that one. Times 2. This one plus 10. Okay, watch out for that 4. There we go. I still blew it. 10 times 2 times negative 3 to the 9th. There we go. Minus 393,660 x, y to the 9th. And then finally, my last one, I have, this is 10, this is 1, and this is 1. And so we've got 59049 y to the 10th. And there's our expansion. Wow, that's a lot of stuff. Yeah. Test worthy? 10's a bit much. 7? Sure. Because 7 might do it with Pascal's triangle. You might find it easier with combinations. But you do need to be able to do these expansions for our unit assessment. Okay? All right. Should we have a quiz on this tomorrow? Ask Mr. Paz. Have a fabulous day, everyone. Take care.